All right, so what this section is about, this third section is about analyzing data. And the big thing here, what we're looking at is that we're looking at, okay, how to find the central tendencies of data that is very large and with a lot of it. And, you know, how are we going to understand what this is saying based on all these number and data points that we have? And given enough data points, you can almost be able to prove, not prove, but you can say with good probability that, you know, this is going to occur, or this isn't going to occur, and that type of thing. And that's what statistics can do. And so what we're going to be looking at first is that we're going to be looking at measuring central tendencies. And so measuring central tendencies, we're kind of finding where is the middle of all this data. Okay. And so the first thing that we have is the mean, and the mean is the average of all the data points. Okay, and that's what we're talking about. Whenever we say mean, we're not talking about like, you know, Mr. Burns mean type, like a person is mean. No, we're talking about average. And so the average is also called the mean. Okay, hopefully this isn't new stuff. Algebra 1 should have covered this and many other things. But your average of them all is called your mean. So you take all the data points, add them all together, and then divide by how many data points there are. After that, we have our median, and our median is our middle number. What number is in the middle of all this data? So you would list it from smallest to largest and find the exact middle. This is also the 50th percentile or the second quartile. We talk about that later. Last one is called the mode, and the mode is whatever one appears most frequently. Okay, so if this one occurs 8 times and none other occur more than 5, that data point would be considered the mode, okay, because it occurs the most. These are different ways of identifying where the middle or the central tendency of all the data is. It depends. Depending on the size of the data, sometimes it's not going to get you what the actual number is. It usually won't get you what the actual number is, but it's just another way of identifying. You can go, okay, this one occurs most frequently. This one is the middle of all the numbers. This is the average. Okay, most people like using the average and the median for these. All right, so when we're talking about analyzing data, what we need is data. And so you can take data from almost anything that you can observe and write down the information. And so what I've got here is that I've got 4 cities on the West Coast. I've got Seattle, Portland, South Lake Tahoe, and San Diego. Okay, so 2 in California, 1 in Oregon, and 1 in Washington. And this data right here, do you think you can guess what it is? It's the average high temperature of each month for each of these cities. Okay, so it's the average high for each one. And so if we have all this data, you're going, okay, well, what are we going to do with it? Well, it depends on what you want to do with it. You want to see, okay, if you want to statistically prove that Seattle is colder than Portland, or Lake Tahoe is colder than Seattle, or San Diego is the warmest out of all of them, we can do that statistically. Okay, we're not going to do that in this one. What we're going to be looking at is we're going to see, okay, what is the middle of all these numbers? Okay, and so with all these numbers, what you're going to do is you're going to use your calculator, and you're going to use the list function on your calculator. So when you go stat edit, and when you go stat edit, what's going to happen is that you're going to have all these or stat edit under L1, you're going to put all these numbers in. Doesn't matter what order, if you put them all under L1, that's all you need. So you end up with about 48 data points in this case. And when you do that, what you're going to do is you're going to have the calculator do all these calculations for you. You know, do what calculators do best. And so what you'll do is you go second stat, which should be blue. It should say list on it. That's blue above the button. This is with a 83 or 84, the TIs. 83 and 84s is what I'm going off of. And so if we go there, if we go second stat, so it's list, we go over to math. So you use the little slide and go over to math. You'll see min, max, median, mean, and all that. And so what you do is you go down to mean, and then you go second 1. That should pop up L1. Push enter, and it should tell you the average, which ends up being about 62.875. So that was the average of all of them. Now, if you want to find the median, you do the same thing. Go second stat, go over to math, and you'll see median is on mine. It's for the 84. It's for an older 84 plus. It's number 4, and so that's your median. You do the same thing, and you see you get 65. Okay. All right. Now, Another way of displaying data and seeing where the central tendency is by using what's called the box and whisker plot, okay, or a box plot. And a box and whisker plot, what you'll need is you'll need five pieces of information, okay. 3 of the pieces of information are called your quartiles. Now, what a quartile does is it divides the information up into 4 equal parts, okay, into quarters, okay, and you need your 3 points. So what I want you to do is I want you to put all these numbers, you're going to want to pause the video because I'm going to move on. Put all these numbers into your L1 list, okay? So type in all those into your L1 list right now. Okay, good. Now, under L1, once you have all those, what you're going to do is you need to identify these 5 things. So this is called your 5-point summary. 5-point summary, okay? And your 5-point summary tells you the information you need for your box and whisker. Okay, you need your minimum, your first quartile, your second quartile, which is called your median, and also your third quartile. And then the last thing is your maximum. Okay, so those are the 5 points that you need. Now your calculator can find all 5 of those for you pretty simply. Once you have them into L1, what you're going to do is you're going to push stat again, go over to calc, and you'll see something that says 1 vars, or no, it's just 1 var stats. Push enter, make sure it says L1, or make sure that it's for L1. Push enter again, and you'll see stuff. It says like x bar, sigma x squared, s of x, lowercase sigma of x, and so on and so forth. But you should be able to slide down, and you'll see min, Q1, median, Q3, and max. Okay, and those are your numbers. So your min was 56, your quartile was 60.5. Your median was 72.5, your third was 83, and your maximum was 86. Now what you're going to do is you're going to plot all these points on a number line. Okay, so 56, 86, I don't know, about 72 is probably about there, 72.5, 60.5 is about there, and 83 is about there, approximately. And then what you're going to do is you're going to box your quartiles all together. Okay? And that is your box and whisker plot. As you see, you have your box and you have your whiskers coming off on either side. Okay? So that's your box and whisker. All right, your percentiles. Percentile rank is a way of helping us identify where a piece of data lands in a given data set. And so it gives us the percentage and what it is. So if you ever look at your SAT or other test scores, you might see, oh, I'm in the 58th percentile, I'm in the 34th percentile, I'm in the 94th percentile. They give you a percentile rank. That tells you where you rank compared to the other people that took the test. Now, the way of calculating where, like position-wise, you are, what you're going to want to do is you want to find like how many people did worse than you, how many people did better than you. So we've got this situation with Sally. Sally took the SAT in Wyoming, that one state, and there was about 2,500 people that took it along with her. She finished in the 46th percentile. We want to know how many people did worse, how many people did better than her. Okay, so 46th percentile, 2,500. To find this, what you're going to do is you're going to take the total number of data points, 2500, and multiply it by her percentile as a decimal, 0.46. Okay, multiply that together and you see that you get about 1,150 students. So there's about 1,150 students that did worse than Sally. Now to find how many people did better, you're going to take the total number, 250, and multiply by 1 minus her percentile. So her percentile was 46. That means that you go 1 minus 0.46, which would be 0.54. And you're going to go 250 times 0.54, in which you get about 1,350 students did better than her. So again, this is an estimation of how many people did better and how many people did worse than somebody did given a certain percentile. So when you have your percentile, find out how many people there were, and you can see how many people did better than you and how many people did worse than you. Estimating, okay? So as you see, if you add those two together, you get the total number of people that took it. So again, this is estimating how many people above and how many people below, obviously. But that's just dealing with percentile. So whenever you're given your percentile, what you're going to be looking at is you're saying, okay, I'm at the 64th percent. That means that out of everybody that took it, I would be, if there was 100 people that took it, I would be 64th. And there would only be about 36 people that are above me, approximately. Okay. And so the higher the percentage, the better, in quotations, the better you would be by thinking with the percentile rank. Okay, so the higher number is better because it means you're above 50% is average, so you usually want to be above average. All right, outliers. So outliers are numbers that do not fit with the data. So if you look at this one, we have 1, 5, 3, 4, 7, 2, 4, 5, 26, 2, and 4. Which one of these looks like it does not fit? And well, that number is obviously 20. Okay, all the other ones are single digit, nothing higher than 7, and then we've got this 20. Outliers occur a lot. It could be just a mess up with an experiment. It could be some sort of force of nature that occurs and makes this perfect situation happen that it occurs. But outliers happen. And for us to identify if something is an outlier, what you would do is you'll take the third quartile if the number is bigger. So like this 20 right here. This 20. What you would do is that you'll look at the third quartile and identify what the third quartile is. So once you have all that. And then what you're going to do is you're going to find what's called the interquartile range, the IQR, which is the largest, or the third quartile minus the first quartile. Multiply that number by 1.5, and then add it to the third quartile. And if your number is larger than that number, if the number in the data point is larger than the number that you solved there, that means that it is an outlier. Now, if it's a number that's really small, then you just go 1 minus the interquartile range times 1.5. And if your number is still smaller than that number that you calculated, so your data point is still even smaller, it's an outlier. Okay. Outliers don't occur too often, but they can, and this is kind of the way to identify if it is or not, okay, besides just looking at it. All right, so your IRAT for this one, what you're going to do is you're going to find the mean, mode, and median of that data set. It's not in order, so you're going to have to put it in order. Well, you don't have to. Use your calculator, okay, makes life easy. Use your calculator, get used to using that statistics functions on it. And the next one, you're going to create a box and whisker plot based on this data. So this one I have given you the numbers in order. Make a box and whisker plot. So again, find your 5-point summary, your minimum, first quartile, median, third quartile, maximum. Graph all those. Make your box and your whiskers. Okay. So that's just a way of looking for central tendencies in raw data.